An admission fee of $10 plus $2 per ride. Choose variables to represent the total cost in dollars. Total cost I will always call C. And the number of rides, I'm going to use the letter R for rides, that are taken. Write an equation that relates the total cost of the number of rides. So C, our cost, is going to equal $10 plus $2 per ride. That's what your equation should look like. And now we're going to graph that thing. So to graph this thing at this stage, all of you guys are equipped to do is create a table of values, pick up some points, and shove them in the equation. So rather than label this thing X and Y, it's going to be our independent variable and our dependent variable. In this case, the independent variable is what? Sorry? R, the number of rides. Because the cost depends on the rides, not the other way around. So I'll pick some values here. What is the least value that we can have for R? 0. You can't have negative values for rides. How can you negatively go on a ride? You can't. So the smallest value that we can have for R is 0. And so I'll pick some values. I picked 1, 2, and 10 in addition to 0. I'm going to plug them into the equation and I'm going to graph these points. If R is equal to 0, 2 times 0 is 0. 0 plus 10 is 10. If R is 1, 1 goes in for R. 2 times 1 is 2 plus 10 is 12. If 2 goes in for R, 2 times 2 is 4 plus 10 is 14. If 10 goes in for R, 2 times 10 is 20 plus 10 is 30. So those are going to be my points that I want to graph. This is how I graphed it. I put R along the bottom, and I call, just to give me some space, I went up every 4 lines, and I said, okay, well, that's 1 ride, 2 rides, 3 rides, 4 rides, all the way up to 10 rides, just to spread it out, make it look, I don't know, bigger. And then up this side, I said that every 2 squares was $1. So then I would have graphed my points. The points I graphed were 0 and 10 were that guy there. 1 and 12 were that guy there. 2 and 14 were that guy there. And then I went all the way to the end and I graphed 10 and 30. Why did I not connect the dots on this? There's a reason that the dots were not connected. What is it? Scarlett? You can't have a fraction of a ride. It's not like you show up at the ride and say, I want to get off the halfway point. So if you could just stop it for me, that'd be great, and I'm only going to pay you $1. Or, you know what, I'm good for about the first quarter of the ride, but that hill there is really big and scary. So I'd like to ride the roller coaster to the bottom of the first hill. You're going to stop it for me, and I'm going to get out, and I'm only going to pay you 25 cents for that. That's not an option. Like, you pay for the $2, and you get on the ride, and whether you love it or hate it, you ride the whole ride. That's the way it goes. So because of that, I can't have fractional rides. I'm not connecting the dots. What we could do, though, is there's a pattern here. For every $1 spent, it goes up. For every ride ridden, you go up $2. Every ride ridden, you go up $2. You ride another ride, $2 more. Another ride, $2 more. And so I filled in all of the possible costs for all of the rides up to 10 rides, but you cannot connect the dots because conceptually it doesn't make sense. So then part C says, what is the total cost for 7 rides? So you just got to go down to the bottom. You find where it says 7 rides. You go up to where that point is, right there, and you follow that over and said, okay, well, it's $24. You can read it right off the graph that I made. For the last part, it says how many rides can be ridden for a total of $38. I didn't go up to 38. I mean, we could. We could extend what I did. Or I will demonstrate for you another way to do this. In the last chapter we did, we did a lot of this stuff. We have our equation, and we are told to figure out how many rides were for $38. Well, 38's a cost, so the equation is going to become 38 equals 10 plus 2r. This is the kind of thing you should be able to solve after last chapter for r. I'm going to subtract 10, we'll subtract 10. Here they cancel. We're going to get 28 equals 2r. This 2r is 2 times r. The opposite of multiplication is division. Divide by 2, and r is going to equal 14 rides. If you spent $38 at the fair or the amusement park or whatever this place is, you had to have gone on 14 rides. Questions, comments, concerns about 13? Okay. Hearing nothing. Let's look at 15. 15, a small plane is at a height of 1,800 meters. When it starts to descend, when it starts descending to land. I mean, you don't necessarily need to know what descending means. The plane starts up and it's landing, so in the in-between it goes down. And it says the plane's height changes at an average rate of 150 meters per minute. Choose variables to represent the height, I'm going to call that h, in meters, and the time, t, in minutes. We're going to write an equation that relates the height to the time. What is that equation going to be? The height is equal to what? How do I turn 1,800 meters and then descending to land into an equation? Yes, Hassan John. You betcha. 1,800 is where you're starting, and from there you're taking away 150 meters every minute, where t is the time in minutes. You betcha. So I am going to pick some values for time. Time is independent, height is dependent. Time is going to march, well, do we have a minimum value for time? What's the least amount of time for the problem? Anybody? Am I allowed to have negative time? No. So the least height is 0, or the least time is 0. And let's put some values in there to get an idea of what's going on here. 1, 2, 3, 4. And if we plug these values in, we're going to get some heights, some altitudes at different times. So if I plug 0 in here, it's going to be 1,800 minus 0. Well, that's just going to be 1,800. I plug 1 in here. 150 times 1 is 150. 1,800 minus 150 is 1,650. If I plug 2 in here, 150 times 2 is 300. 1,800 minus 300 is 1,500. If I plug 3 in here, that's going to be 4,500. Sorry, 450. You betcha. Well, 1,350. If I plug 4 in here, that's going to be 600. 1,800 minus 600 is 1,200. So then these are the points I'm going to graph. Before I do that, am I allowed to connect these points or not? I heard a whisper of a yes over here. Josh, was that you? Faison, that was you. Carson, that was you. Okay, it's right. Matab, was that you? It was Faison. Faison, you're right. We can connect the dots. Why is Faison right, Josh? Because Faison's off the hook. Well, this one went into pattern 2, but we couldn't connect these dots. We couldn't connect these dots because you cannot have fractional rides. Am I allowed to have fractional time? Yes. Am I allowed to have fractional heights? Yes. So because these things are both allowed to exist in any fraction we want, I'm allowed to connect those dots. Does that make sense? Okay. So then, this graph looks like this. I graphed these points. I said, okay, well, I went up. I said every 2 lines, if you look at our data here, I either have ends in a 0 or it ends in 50. So what I did was I said that every 2 lines upwards is going to be 100 meters, because that gives me a nice little 50-meter break here in the middle. So 2 lines 100, 2 lines 200, 300, 400, 500, all the way up to 1800. And to give me some lateral space to work, I said, okay, well, I'm going to call every minute 2 squares. I could have gone 4 squares, I guess, but I chose every 2. And then I plotted these points. 0 time, 1800 meters. 1, 1650. 2, 1500. 3 was 1350. And 4 was 1200. And then I connected these dots and got all the way down to 12 seconds. The thing hits the ground. Is my altitude allowed to go below 0? So in an appropriate airplane landing, no. We do not want to make a crater in the runway. You want to be able to walk away from your landing in a perfect world. So it stops at 0. That happens at 12 minutes. And then we're asked 2 questions, C and D. What is the height of the plane 6 minutes in? Well, I went to 6 minutes on my data. I went up to the line and over. At 6 minutes, we're at 900 meters. And then the last one says, when is the plane 100 meters above the ground? So I'm going to zoom in to show you what I did. I went to 100 and then I went over. If you look really closely at the blurry picture that's on the screen, that line does not go through 11 and a half. It's earlier than 11 and a half. So if you said 11 and a half, I don't know exactly what it is, but I know 11 and a half is wrong. It's definitively wrong, because this line it doesn't punch through that point there. So you could say 11.4, you could say 11.3, you could say 11 and a quarter if you wanted to. But we know it's bigger than 11, and we know it's less than 11 and a half, and we know it's closer to 11 and a half than it is to 11 and a quarter. So somewhere between 11.25, this guy is somewhere between 11.25 and 11.5. We know it's not either one of those if you've drawn your graph correctly. So you can answer anything in there. 11.3, 11.4, 11.45, 11.33333. Because if you actually plug it into the equation, if you put 100 in here and solve it, I think it's actually 11.3 repeating. If you actually do the math, it's 11 and a third. But that is how you do the 2 questions I assigned yesterday. If you have not taken the time to look at those, please do. It's not super complicated, I don't think. It's all skills that you guys have. But if you wait to the chapter test, which is next Thursday, to do that for the first time, you're setting yourself up to panic, forget, and then just not have anything to do. It's your birthday. I thought you just said it was on my birthday. Yeah, that's what I mean. It's your birthday. Well, it will be your birthday. The day of it. So I apologize for such a horrendous birthday present. But I'm not saving this test till after the break. Sorry?
I think you did that on my birthday too.
Wow, I apologize. I think I apologize to you for that too. Except you might enjoy it. I don't know. Maybe that was a gift for you. I don't know. So that is what we did yesterday. If you have questions on any of that stuff, please let me know. Get the help you need. Otherwise, what I'd like you to do is flip the page. Today's lesson is not overly complex, but stuff we do need to talk about. Here we go. I'm going to take this. Put this guy there so I don't lose it. Okay, so a little bit of an investigation here. Let's talk about this. I have 4 equations here. We're going to create a table of values for all 4. And we're going to graph the thing. Okay, first one, letter A. X equals 1. What does that even mean? Anybody? Thoughts on x equals 1? Well, if x equals 1 and I need to create a table of values, what do we know? Sorry, Carson. You look like you had a thought. You started saying something even. I saw you lie. You totally did. What do we know? Look at the equation. What does the equation tell you? That x is 1. So if x is 1, filling in my table of values here is going to be really kind of pointless, right? X is 1. Is x allowed to be anything other than 1? No. X is 1. If that's our equation, and y doesn't even show up there at all, does it matter what y is? If x is 1, I tell you, x is 1. What about y? I don't know. I don't care. Y can be whatever you want it to be. X is 1. It's locked in. By definition of that little sign there, x is always 1. So it doesn't matter. Y could be 0. Y could be -5. It could be 20. It doesn't matter. 7, 3, whatever it is, y can be whatever you want. X is 1. Well, then how does that show up on the graph? Let's plug some of these points in there. If x is 1 and y is -5, I'm going to go over 1 in the x, and we're going to go down 5 in the y. There it is. If y is 0, well, I'm going to go over 1 in the x. Y is 0. There's that point. If x is 1 and y is 20, we're up here somewhere. 1 and 20. If it's 7, we're right there somewhere. If it's 3, we're right there somewhere. There's nothing stopping me from connecting the dots, so let's connect the dots. So x is 1 is what kind of line? Sorry? The x-axis is this one here. The y-axis is it's just beside it. But it's parallel to the y-axis, right? So it's parallel to the y-axis is up and down. You're looking for the other word, Acom. Vertical. X equals 1 is going to be a vertical line. A vertical line where? Well, it's a vertical line where x equals 1. The thing is not allowed to move side to side. It's locked in. Y can be whatever you want it to be. There's no restriction on values there. So similarly, if I tell you that x equals -3, x is just going to be -3. It just is. You can pick whatever value for y you want. Emerson, pick a number between -10 and 10. Messiah, same question. Josh. Carson. Lola. Wow, only one person picked a negative number. Okay, let's plot the points. It doesn't matter what y is. X is -3. So here we go. -3, -6 is right down there. -3 and 7, way up there. -3 and 3, right there. -3 and 5, right there. -3 and 4, right there. Connect the points. You got a vertical line again. X is locked in, Y is allowed to change. So you get a line that goes straight up and down, vertical, where X equals -3. Cool. So if X equals a number is a vertical line, anyone want to take a stab at what happens when Y equals something? Bless you. It would make a lot of sense if it was the other one. Let's verify it. Yes, Lucas. You betcha. Sorry? Good? Okay, never mind. Sorry, Lucas, keep going. Yeah, so the X can be whatever you want. You can move side to side now. So we're going to get, I don't know, let's pick some values here. -1, 0, 1, 2, 3. You pick whatever you want here. This is locked in. So -1 and 2 is right there. -1 or 0 and 2 is there. 1, 2 is there. 2, 2 is there. 3, 2 is there. And we get, as Lucas said, these are straight too. A horizontal line. So this is going to be a horizontal line. Where Y equals 2. So then what's this one going to look like? I'm not even sure. I need to plug in the points for this guy. Y is locked. Maybe we do. Y is locked in at -4. -4, -4, -4, -4. And it does not matter what X is. So what's this line going to look like? Well, let's go down to where Y equals -4. And if X is allowed to be anything, it's going to grow out from the Y-axis in another direction. Again, a horizontal line. So when you're ready, flip the page. Here it is. The graph of the equation X equals A, where A is a constant. So some number, any number. Pick a number for A. That will always be a vertical line. Every point on this line is going to have that X coordinate, whatever that number is. Likewise, the equation Y equals A, where A is just some number, any number, will always be a horizontal line, and every point on that line is going to have the Y coordinate of A. Something like that, for whatever value A is. So, given some of these lines, what are their equations? Well, if that's a vertical line, what variable is locked? X. So this line is going to be X equals something. What is it? Sorry? Austin Joe? X equals 2. You betcha. You go over, it's 2 to the right. There it is. That's the equation. Now with this guy. You betcha. And this is going to be X equals 1. If you move to the right, it's positive. If you're moving left, it's negative. And if the line is straight up and down, X is locked. Likewise, if you have horizontal lines, the Y is locked. Yes, Lucas, Y equals 3. Y equals -1. And Y equals -2. There it is. Flip the page. So we can draw some of these. I want to graph the following equations and then describe the graph. The description of the graph is the stuff we've already done. It's, you tell me if it's a vertical line or a horizontal line, you tell me where it is. So X equals 3. Without doing a table of values, what's that going to look like? You go 3 to the right and you go up and down. Done. How about this guy? 2 to the left. You betcha. Up and down. And this one, what do you mean you don't move? Right down the middle. So this line, x equals 0, is also known by what other name? That line has a name. It's the y-axis. Very good. The line x equals 0 is the equation for the y-axis. Okay. Y equals 1 is going to look like what? We're going to go up 1 and then side to side. Down 1.5. So if you go down 1, down half a square and out. And this one is the x-axis. Good. I hope you're all working as fast as Lucas is, because he just cranked those out. So the vertical and horizontal, again, not difficult, but you got to make sure you keep it straight. If a x value is locked, that means y can be whatever, it goes up and down. If a y value is locked, that means x can be whatever, goes left and right. And then, this is what we've been graphing. This second last example, example 3 here, is what we've been doing already. We've been graphing equations that have x's and y's in them already. We say that an equation that has both of these things is an oblique line. Oblique just means it's angled. It goes off at some diagonal. So with these, we actually have to plug in at this stage. We won't always, but at this stage, we have to plug in a table of values and solve this thing. If I have 3x minus 2y equals 6, and I'm giving you, for this question, I'm saying make a table of values for x equals -4, 0, and 4, and then graph this thing. There are 2 ways that you can go about doing this. You could, if you wanted to, plug -4 in for x, and then isolate for y. And then plug 0 in for x, and isolate for y. Plug 4 in for x, and isolate for y. Or you could take this equation and isolate the equation to start, and then plug your values in. It doesn't matter which way you choose to do it. So what do you guys want me to demonstrate? Plugging in the values and isolating each one, or isolating for y to start? Hands up for, I want to plug in each value before we isolate. Hands up for, let's isolate the thing once, because it'll be less work. Okay. As soon as I said less work, more hands went up. It is less work. We're isolating once instead of 3 times. So let's do that. I want to get y by itself. To get y by itself, we leave this -2y alone, and we start by getting rid of this 3x, just like we did last chapter. This 3x is positive. I want to get rid of it. How do I get rid of positive 3x? Take it away, you betcha. Subtract 3x on both sides. On the left, it cancels, and I'm going to left with -2y equals, I'm going to get 6 minus 3x. Now I've got -2y equals 6 minus 3x. I want to get y by itself. So the -2 and the y are attached by, you betcha, multiplying. So to undo that, I have to divide. And whatever I do to one side, I have to do to everything on the other side. I'm going to be left with y. And now let's simplify. 6 divided by -2 is -3. And then I have -3 divided by -2. I'm going to leave this as a fraction to make our life simpler. But the negative divided by a negative is going to make this thing positive. So this is going to become -3 plus 3x over 2. And believe it or not, leaving that as a fraction is going to make our life easier. What we're going to do now is we're going to take these 3 values and we're going to plug it into this equation. I'm going to go -4, 0, and 4. What other values would work to put in here? What other smart values could you pick?
Evens.
Anything even. So the next easiest even after 0 would be -2 and 2. We could plug those in there as well. But the question says -4, 0, and 4, so let's do that. To plug those in, I'm going to, just like we've been doing, I'm going to put brackets where the x is, and I'm going to plug that value in. So we're going to get y equals -3 plus 3 brackets over 2, and I'm going to take that -4 and plug it in. And now we bedmass. 3 times -4 is? -12. -12 divided by 2 is? -6. -3 plus -6 is? -9. Or you could just ram that thing through a calculator. Plugging in 0 is going to be awesome, because 3 times 0 is? Divided by 2 is? -3 is? -3. And then the last one, I'll write this one out too. It's more involved. -3 plus 3 bracket bracket divided by 2. I'm going to put that 4 in where the brackets are. 3 times 4 is? Divided by 2 is? Sorry? -3 is? Yes, 6 minus 3 is 3. So we can graph these points now. -4 and 9 means I go over -4 and down to -9. I'm going to have 0, which means I don't move left and right, and -3 is right there. And then I'm going to have +4, which means I go that way, and I go up 3. That thing is linear. I can connect the dots, and I get a line that goes off at some sort of angle. We call that thing oblique. And there it is. I've got one more example for you if you flip the page, and then I'm done. So that our basketball player can get out of here with plenty of time to spare. Here we go. So we're not even going to graph now. Acom. We're not even going to graph now. Our girls basketball players are leaving. You're just going to tell me if it's vertical, horizontal, or oblique, and that's it. X equals 3 means X is locked. What kind of line is that? It's a vertical line. If I asked you to describe it, you would just tell me how to get there. If it's +3, that means we've moved 3 to the right. Good. This line, X equals -3, is also going to be vertical. And it's going to be 3 to the left. That one's horizontal because Y is locked. We're going to go this way. This one's oblique because it's got X's and Y's in there. Lucas already answered E. It's already horizontal. And we went down 2 to get there. And then this last guy has X's and Y's in the equation. So that's oblique as well. That's it. Done. You have so much time. Here's what we're going to do. Here's your homework. And there's a couple pages. I want you to do questions 2 to 14. Almost all of it. On your market set giver.